Your e-bike is making a noise it has never made before, or the brakes feel wrong, or the display is doing something strange and you have absolutely no idea what it means. And your first instinct is to book it into the shop, wait 2 weeks for an appointment, pay a labor rate that makes your eyes water, and get it back with a vague explanation and a bill that hurts. Here is what most e-bike owners do not realize. A significant number of the most common e-bike problems are completely fixable at home by you with basic tools in under an hour. No mechanical background required, no specialist equipment, just the right information delivered clearly. That is exactly what this video is. Why most riders think they cannot do this, and why they are wrong. Let us address the hesitation directly before we get into the actual repairs, because it is real and it is understandable, and it is also almost entirely unfounded for the repairs we are covering today. E-bikes have a reputation for being intimidatingly complex. Motor, battery, controller, display, wiring harness, sensors. And yes, some of that stuff genuinely is complex and genuinely should be handled by a trained technician with specialist diagnostic equipment. Nobody is suggesting you rebuild a Bosch motor in your kitchen on a Sunday afternoon. That is not this video. But here's the thing that the bike shop industry has a commercial interest in not telling you. The motor and battery systems, which are genuinely complex, rarely need servicing in the ways that most riders think. The repairs that actually come up most frequently in real-world ownership are not electrical mysteries. They are fundamentally mechanical. Brake pads, cables, tires, chains, derailleur adjustments, bearing preload. These are things that e-bikes share completely with regular bicycles, and they are things that regular cyclists have been fixing in their garages and living rooms for generations. The electrical integration of an e-bike does not make these mechanical tasks harder. In most cases, it makes no difference whatsoever. A brake pad on an e-bike is the same brake pad as on a regular bike. A chain on an e-bike stretches and wears exactly the same way as a chain on a regular bike. A flat tire on an e-bike is the same flat tire, just on a slightly heavier machine. The tools required are the same, the process is the same, the result is the same. What you need to do these repairs successfully is the right information in the right order, a basic set of tools that costs less than a single shop visit, and the confidence that comes from understanding exactly what you are doing and why. By the end of this video, you will have all three. Repair 1. Fixing a flat tire. It is genuinely the same job, just with a heavier bike to manage. First, get the bike stable. If you have a repair stand, use it. If not, flip the bike carefully onto its handlebars and saddle on a flat surface or lean it against a wall. For a rear flat, shift to the smallest sprocket before you start. This makes wheel removal significantly easier. Disconnect the brake if it is a rim brake before trying to remove the wheel. Disc brake bikes, which most e-bikes are, can stay connected. Remove the wheel. Rear wheels on e-bikes with hub motors require a little extra attention. There will be a motor cable connector that needs to be carefully unplugged before the wheel comes fully free. Do not yank it. Locate the connector, squeeze the release tab if there is one, and separate it cleanly. Set the wheel down on a clean surface. Use tire levers, 2 is usually enough, to work the tire bead off one side of the rim. Start opposite the valve, work the lever under the bead, and walk it around the rim. Once one side is off, you can pull the inner tube out completely. Find the puncture by inflating the tube slightly and listening or feeling for escaping air, or by running it slowly past your lips, which are surprisingly sensitive to airflow. Mark the hole with a pin. Patch or replace the tube. Replacement is faster and more reliable for most riders. Before fitting the new tube, run your fingers carefully around the inside of the tire to find whatever caused the puncture. If it is still in there, a thorn, a piece of glass, remove it completely or you will flat again immediately. Fit the new tube, reseat the tire bead by hand. Use levers only as a last resort to avoid pinching the tube. Inflate to the recommended pressure printed on the tire sidewall. Reconnect any motor cables you disconnected, refit the wheel, and you are done. Total time once you have done it once or twice, 15 to 20 minutes. Repair 2, adjusting brake pad. Alignment. Squealing brakes are one of the most common complaints among e-bike riders, and the cause is almost always one of two things: contaminated pads or misaligned pads. Contamination requires new pads. Misalignment is a 5-minute fix. For hydraulic disc brakes, which is what most quality e-bikes have, the caliper needs to sit centrally over the rotor so that both pads make even contact when the lever is pulled. Loosen the 2 bolts that mount the caliper to the frame or fork just enough that the caliper can move slightly but does not fall off. Squeeze the brake lever firmly and hold it. This centers the caliper automatically against the rotor. While holding the lever, tighten the caliper bolts back down evenly, alternating between them. Release the lever. Spin the wheel. In most cases, the squeal is gone and the brake feels noticeably better. That is genuinely it. 2 bolts, 1 lever squeeze. Done. If the rotor itself is slightly bent, you will see it as a wobble when the wheel spins. A rotor truing tool or even careful use of an adjustable spanner on the specific bent section can straighten it. Go slowly, make small adjustments, and check after each one. Repair 3. Replacing brake pads. When your brakes start feeling spongy or less powerful than they used to, or when you can see that the pad material is worn down to less than a millimeter of thickness, the pads need replacing. This is not optional. Riding on worn pads damages your rotors, which are significantly more expensive than the pads themselves. Fix this early. Remove the wheel. Locate the retaining pin or bolt that holds the brake pads in the caliper. Most hydraulic calipers use a small pin secured with a split pin or a bolt. Remove the retaining hardware and slide the old pads out. Note which way they came out. Photograph it with your phone if that helps. Before fitting the new pads, use a flat tire lever or a dedicated pad spreader tool to gently push the caliper pistons back into their bores. New pads are thicker than worn ones and need the extra space. New pads go in the same orientation the old ones came out. Replace the retaining pin or bolt. Refit the wheel. Bed the new pads in by doing 10 to 15 stops from moderate speed. This seats the pad material against the rotor surface and dramatically improves initial braking performance. Total time, including wheel removal and refitting, 20 to 30 minutes. Repair 4. Lubricating and replacing a chain. A dry or worn chain is one of the single most damaging things you can allow to persist on any bike. It wears your chain rings and sprockets dramatically faster than a properly maintained chain does, and chain ring and sprocket replacement costs many times what chain maintenance costs. This one is about protecting your investment. Chain lubrication first. Wipe the existing chain thoroughly with a clean dry rag to remove old lubricant, dirt, and grit, all of which act as grinding compound against your drivetrain components when combined. Apply fresh chain lubricant, wet lube for rainy conditions, dry lube for dry conditions, to the inner side of the chain, 1 drop per link, rotating the cranks backwards slowly to work through the whole chain. Wipe off the excess. Done. Do this every 200 to 300 kilometers of riding and your drivetrain will last significantly longer. Chain replacement is the next step when a chain wear indicator tool, which costs under $10 and is worth every cent, shows the chain has stretched beyond the replacement threshold. Most chains use a master link for joining and removal, which makes the job straightforward. Use a master link pliers tool to remove the old master link, slide the chain off, thread the new chain through the derailleur in exactly the same path as the old one, connect the new master link, and snap it closed by backpedaling with light resistance applied. Check that the master link is fully seated. A partial engagement is a safety issue. The whole job takes under 20 minutes once you are familiar with the process. Repair 5. Adjusting derailleur. Indexing gears that skip, refuse to engage, or crunch when you shift are almost always a cable tension issue rather than a mechanical failure. Indexing adjustment is one of the most satisfying repairs on this list because the fix is immediate, obvious, and requires only your fingers and a small screwdriver. With the bike in the smallest sprocket at the rear, shift up 1 gear. If the chain is slow to move up to the next sprocket, hesitates, skips, or will not go, you need more cable tension. Turn the barrel adjuster at the rear derailleur or at the shifter body anti-clockwise. This adds tension to the cable. Make small adjustments, half a turn at a time, testing the shift after each one. If the chain shifts up 2 sprockets instead of 1 or makes noise in the engaged gear, you have too much tension. Turn the barrel adjuster clockwise to reduce it. Work through the full range of gears once the middle of the cassette feels correct, confirming each gear engages cleanly before moving to the next. The whole adjustment process typically takes under 10 minutes and transforms a bike that felt broken into one that feels new. Repair 6. Tightening a loose headset. A loose headset, the bearing assembly that allows your front fork and handlebars to turn, creates a distinctive clunking sensation when you apply the front brake and rock the bike forward. If you feel that clunk, fix it immediately. A loose headset affects steering precision and gets worse quickly if ignored. Check the diagnosis first. Hold the front brake lever firmly and rock the bike forward and back. A clunk that you can feel through the handlebars confirms a loose headset. On most modern e-bikes with a threadless headset, which is almost everything built in the last 15 years, the fix is straightforward. Loosen the 2 bolts on the stem clamp that holds the stem to the fork steerer tube. Tighten the top cap bolt, the single bolt in the very center of the top of the stem, gradually and incrementally until the clunking disappears when you repeat the rock test. Do not over-tighten. There should be 0 play, but the fork should rotate completely smoothly with no binding or resistance. Once the play is gone, re-tighten the stem clamp bolts evenly. Recheck. The whole process takes 5 minutes maximum. Repair 7. Truing a wheel. A slightly buckled wheel, that's one that wobbles side to side as it spins, creates brake rub, uneven tire wear, and in more severe cases genuinely affects handling stability. Minor truing is absolutely within the reach of a patient home mechanic with a spoke key and 15 minutes to spare. Spin the wheel slowly and watch where it deviates from straight. Mark the problem area with a piece of tape or a pin mark on the tire if it helps you track it. On the side the wheel deviates toward, tighten the spokes slightly. Quarter turns only, never more. On the opposite side, loosen the spokes by the same amount to maintain even tension across the wheel. Work gradually and check after every adjustment. The goal is small incremental corrections rather than large single adjustments. A severely buckled wheel, one that moves more than 3 or 4 millimeters off center, is beyond home truing territory and should go to a shop. But the minor wobbles that develop through normal riding are completely manageable at home, and catching them early prevents them from becoming the severe version. Repair 8. Cleaning and servicing the dropper post or seat post. If your seat post is creaking, sticking, or refusing to stay at the height you set it, the fix is usually simpler than it sounds and dramatically improves day-to-day riding comfort. A creaking seat post on an e-bike is almost always caused by one of 2 things: dirt and grit working into the interface between the post and the frame, or insufficient or degraded grease at that interface. Remove the seat post completely by loosening the seat post clamp and pulling the post straight up out of the frame. Wipe the post down completely with a clean rag. Inspect the frame tube interior with a torch. Clean out any visible grit or debris. Apply a fresh thin layer of carbon assembly paste if the post is carbon, or regular bike grease if the post and frame are aluminum or steel. Reinsert the post to your marked height. Measure and mark your saddle height with tape or a permanent marker before you pull the post so you can return it precisely, and tighten the clamp to the torque specification printed on the clamp itself. That specification matters on e-bikes more than people realize because over-tightening damages frames and under-tightening allows the post to slip. A basic torque wrench set to the correct value takes the guesswork completely out of it. Repair 9. Diagnosing and clearing error codes. This one sounds more technical than every mechanical repair we have covered so far, and in some ways it genuinely is. But here is what most e-bike owners do not realize. The majority of error codes that appear on a real e-bike display in real everyday ownership are not catastrophic system failures. They are soft errors, sensor hiccups, momentary communication glitches between components, low battery warnings that the system has slightly misread and escalated. And for a large proportion of those codes, the fix is something you can do yourself at home in under 5 minutes without a single specialist tool or any technical background whatsoever. The first thing to understand is that every major e-bike motor system has a fully documented error code library. Bosch, Shimano steps, Yamaha, Bros, Every one of them publishes a complete list of every code their system can generate, what each code means in plain language, and what the recommended response to each one is. These lists are available on the manufacturer's website. They are in your owner's manual. They are not hidden behind a dealer portal or locked away from the average owner. They are public, they are free, and they are genuinely useful in a way that most writers never discover, because their first instinct when a code appears is to call the shop rather than open a browser tab. So here's the rule. When a code appears on your display, any code, any system, the first thing you do is look it up, not guess what it might mean. Not assume the worst, not call the shop. Look it up. Find the documented description for that specific code on your specific motor system and read what it actually says. That one step will immediately tell you whether you are dealing with something you can handle yourself or something that genuinely needs professional diagnostic equipment. That distinction alone is worth knowing. Now, the practical process. When a code appears for the first time, start with a power cycle before you do anything else. Turn the display completely off. Wait a full 30 seconds. Not 5, not 10, 30. Turn it back on. Ride normally for a few minutes and see whether the code returns. A surprisingly large number of first-time error code appearances do not return after a simple power cycle because whatever triggered them was transient. A momentary sensor communication drop, a brief voltage fluctuation during a hard acceleration, a temperature reading that spiked and immediately normalized. The system flagged it, you reset it, it is gone. Genuinely, that's simple in more cases than you would expect. If the code returns consistently after a power cycle and the documented description points toward a sensor issue, speed sensor, cadence sensor, torque sensor, then the next step before calling anyone is a physical inspection of that sensor and its associated magnet. Get down and look at the sensor mounting. Check that the magnet on the wheel or the crank arm is still correctly positioned and has not rotated or shifted. Check that the gap between the sensor and the magnet is within the specification in your manual, usually 2 to 3 millimeters. Check that the sensor cable is fully seated in its connector and has not worked loose from vibration over time. A speed sensor magnet that has shifted slightly off position is a 30-second repositioning job. A sensor connector that has vibrated loose is a firm push until it clicks. Neither of those situations requires a technician, a shop appointment, or a labor charge. Hard codes are the exception, and they deserve genuine respect. Codes indicating motor controller failures, battery management system faults, or internal motor failures are telling you something the system cannot recover from on its own and cannot be addressed without specialist diagnostic equipment that reads deeper into the system than any display can show you. The documented code description will tell you clearly when you are in this territory. When you are, call the shop, book the appointment, and go. But know the difference first. Most of the time, it is not that. Repair 10. Bleeding hydraulic brakes. Alright, this is the most technically involved repair on this list, and I want to be honest with you about that up front. Bleeding hydraulic brakes is not difficult, but it does require a specific bleed kit for your brake brand, a clean workspace, some patience, and willingness to follow the process carefully. If your brakes feel spongy, pull a long way to the bar before engaging, or have visible air bubbles in the fluid, you need a bleed. And you can do this yourself. The most common hydraulic brake systems on e-bikes are Shimano and SRAM, and both manufacturers produce their own bleed kits with clear and detailed instructions. Buy the correct kit for your specific brake. This is not a place to improvise with generic equipment. The process and overview, and you should watch the brand-specific video for your exact brake model before doing this the first time, involves attaching a bleed syringe filled with fresh brake fluid to the caliper bleed port, opening the lever reservoir, and using the syringe to push fresh fluid through the system while tapping and squeezing to dislodge air bubbles. The air rises out through the lever reservoir into an attached catch cup. Once the fluid flowing out shows no bubbles, you close the system, clean up any spilled fluid immediately and thoroughly, brake fluid damages paint and carbon fiber, and test the lever feel. A successful bleed transforms a mushy, uncertain brake lever into something that feels immediate, firm, and completely predictable. The difference is remarkable, and it is one of those repairs where doing it yourself for the first time gives you a genuine sense of achievement as well as a significantly better performing bike. Budget 30 to 45 minutes for your first bleed. By the third time you do it, you will be under 20 minutes. Building your home repair kit. Right. So now you know the 10 repairs. Here is exactly what you need to do all of them. The complete home repair kit for an e-bike owner without anything unnecessary on the list. A set of metric Allen keys or a quality multi-tool covering 2mm through to 8mm handles the majority of bolts on any modern e-bike. A torque wrench covering the range of 2 to 25 Nm handles the bolts where getting the torque wrong matters. Stem bolts, seat post clamps, brake caliper mounts, tire levers, 2 or 3 plastic ones, a chain wear indicator tool, a master link pliers, a spoke key sized for your wheels' spoke nipples. Your bike shop can tell you the correct size if you are not sure. A barrel of wet lube and a barrel of dry lube, a chain degreaser, a bleed kit for your specific brake brand if you plan to do the brake bleed, and a torque specification card for your specific bike. Most manufacturers publish these on their website, and printing one out and keeping it with your tools saves a lot of uncertainty. Total cost of this kit assembled thoughtfully from quality but non-premium brands, somewhere between $70 and $120. That is typically less than a single shop visit covering one of the repairs on this list. After the initial investment, every subsequent repair costs you only your time. Towards the bottom line. Your e-bike is a mechanical object. It has moving parts that wear, cables that stretch, pads that thin, chains that stretch and eventually need replacement, bearings that need to be kept properly adjusted. None of that is a problem. It is just normal physics applied to a machine that gets used regularly in the real world. The question is not whether these things will need attention. They will. The question is whether you pay someone else every single time, or whether you build the skills and confidence to handle the routine stuff yourself. Every repair on this list is genuinely learnable. Every single one. The first time you do any of them, it will take longer than the times after it. The second time will be noticeably faster. By the fifth time, most of these will feel completely routine. And that transition from rider who books everything into the shop out of uncertainty to rider who knows their machine and can keep it running well themselves genuinely changes the relationship you have with your bike. It becomes more yours. You understand it better. You ride it with more confidence because you know what it is doing and why. Hit that like button if this gave you confidence to try something you would previously have booked straight into the shop. Drop a comment below telling us which repair you're going to tackle first. We read every single one and we genuinely want to know. Subscribe if you are not already with us because there is a lot more practical content like this coming your way very soon. See you in the next one.